All right, Trig Basics, Unit 9, Day 1. Please take good notes on this because we're going to use this information for a very long time, okay? So, special right triangles. So, we have two types of special right triangles. There's a 45-45-90 triangle and a 30-60-90 triangle. And we use those ratios, so we need to find the ratios of the sides, and we're going to use those a ton, and they're used a ton in geometry and trigonometry and different things. Okay, so first, I want to show you how you can get the ratios for this. So we're going to start with a square right here. In a square, you know all the sides are the same. So I'm just going to draw those tick marks to show that those two sides right there are congruent. Okay. All the angles are 90 degrees, so that corner angle is 90 degrees, which makes that angle 45 degrees. And that top angle right there is also 45 degrees. I just forgot to write that. Okay. Now, if those two sides are the same, let's just label those both x. So that side's x, that side's x. You can also do it with the top and bottom, but we're only working with this triangle right here. So we're just going to label those two sides. Now, in a right triangle, you can use Pythagorean theorem to find your missing side. So we can use Pythagorean theorem to find that hypotenuse. So that's going to be x squared, because that's the first side, plus x squared equals c squared. And then x squared plus x squared is 2x squared equals c squared. Square root both sides. And you get c equals the square root of 2x squared. Well, the square root of 2 is just, let's just leave it as the square root of 2. But the square root of x squared is x. So c equals x square roots of 2. And we can just label that, maybe. Oh, let's go back. Okay, so this right here, this is x square roots of 2. I would write that down. I don't know why I didn't. So write that down. Okay, it's going to go away because I don't know how to do it. But now for this bottom, our first leg is x, second leg is x, the hypotenuse is x squared, so 2. And that's true for all 45, 45, 90 triangles, all of them. The sides are x, and the hypotenuse is always x squared, so 2. That's really, really important to remember. Okay? Let's move on to the 30, 60, 90 triangle. So this is the other triangle that we work with a lot. Now, I'm going to start with an equilateral triangle. So in an equilateral triangle, that means all of the sides are the same. I'm going to call these sides 2x to make things a little bit easier. So all of my sides are 2x instead of x this time. Okay? All my angles are 60 degrees. Maybe. All my angles are 60 degrees, which means that top angle, because we're splitting it in half, is 30 degrees. And then this right here, again, I don't know why I didn't label this. This right here, whoops, that is a 90 degree. So you can label that right now. And we're just going to work with this triangle right there. Okay, this is going to go away again because I can't figure out how to get it to say. Now, if that whole bottom is 2x, half of it is just x. So we're just going to call that piece, the side opposite of 30 degrees is just x. Oh, and there I go, label the right triangle. Again, we're going to use Pythagorean theorem to find the height of this. So x is going to be my a. We don't know b, 2x will be my c. So x squared plus b squared equals 2x squared. So that's x squared plus b squared. 2x squared is 4x squared because you have to square the 2, square the x. Subtract that x squared over and you get b squared equals 3x squared. And then square root both sides. And you get b equals the square root of 3x squared. But the square root of x squared is x, so you can just pull out that x. So b equals x square roots of 3. And that's this length right here, x squared roots of 3. Okay, so if you ever forget these ratios, go back to this and draw that equilateral triangle and figure it out, because you can figure it out from this. Same with the 45, 45, 90 triangle. Go back and draw the square and figure it out from there if you don't remember the ratios. Okay, whoops. Now the shorter leg, so the leg opposite of 30 degrees, is x. The longer leg, the leg opposite of 60 degrees, is x square roots of 3. And then the hypotenuse is 2x. Okay, those are also very important to remember. So shorter leg is the one opposite of 30 degrees. Longer leg is opposite of 60. And then the hypotenuse is the hypotenuse. Okay? So let's actually use this. So let's look at example A. So I put this 45, 45, 90 triangle over here with my sides labeled. Now let's go over to the triangle we have in example A and label my sides x, x, and x squared roots of 2. So my hypotenuse is x squared roots of 2. And then my two sides are x. And I'm just going to rewrite that. So y really equals x squared roots of 2. X equals x. Okay. Now I'm going to go to what I have. I'm given this piece right here. I'm given that x equals 10, which means I can just go and plug it in right there. So x equals 10, and then y equals x squared roots of 2. We'll plug in 10 for that x, and you get 10 square roots of 2. Okay, let's do another example. So let's look at this triangle now. And again, let's label our sides. So we have x squared roots of 2 is my hypotenuse. And then x and y are both x, because both of the legs are x. So x equals x, and y also equals x. And I want you to write that every single time, because it gets confusing because we have like x and y, and then we have these other x's. So just always write if they equal x or if they equal x squared roots of 2. Okay? Now I'm going to take what I'm given. So I'm given the 16 equals the x squared roots of 2. And I'm going to set those equal to each other. I need to solve this for x. So to get that x by itself, I'm going to divide by the square root of 2. Those square roots of 2 cancel, and I'm left with x equals 16 over the square root of 2. Okay, mathematicians do not like having square roots in the denominator. So we have to rationalize that denominator. And what that means is we have to multiply by the square root of 2 to the top and to the bottom. Then we just multiply straight across. So 16 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is 2. Okay? And then let's just reduce this. 16 divided by 2 is 8. So x equals 8 square roots of 2. And then I can just go up and plug that in. So x equals 8 square roots of 2, and y equals x, which also equals 8 square roots of 2. Okay, let's do another one. So again, let's label our sides. So our hypotenuse is x squared roots of 2. My legs are x. So x equals x, y equals x. Now I'm going to take what I know, and I'm going to solve for x. So I have x squared roots of 2 equals 14 square roots of 2. Divide both sides by the square root of 2. Now those both cancel, so I'm just left with x equals 14. So we don't have to rationalize the denominator because we don't have a radical in the denominator. We don't have a square root in the denominator. So that just means x equals 14, y equals x, which equals 14. Okay. Now let's move on to 30, 60, 90 triangles. So again, I'm going to start this the same exact way. I'm going to label my sides. So the hypotenuse is 2x. The side opposite of 30 degrees is x. And then the side opposite of 60 degrees is x square roots of 3. Okay, so x equals x, and y equals x square roots of 3. Then I'm going to take what I know. So I'm given 8 equals 2x. So I just have 2x equals 8. Solve for x, so I'm going to divide both sides by 2. And you get x equals 4. So that means that top one is just x equals 4. Then I'm going to plug 4 in to find out what y equals. So y equals x squared to 3. Well, x equals 4, so I can plug 4 into there, and that's 4 square roots of 3. Okay, let's look at another one. So this one, again, started the same exact way. Hypotenuse is 2x, side opposite of 30 degrees is x. Oh, I did that in a weird order that time. So hypotenuse is 2x, so x equals 2x. The side opposite of 30 degrees is x, so y equals x. And then the side opposite of 60 degrees is x squared, so 3. So 27 equals x square roots of 3. Now I'm going to use that information to solve for x. So I have x squared to 3 equals 27. Divide both sides by the square root of 3, and I get x equals 27 over the square root of 3. Then we have to rationalize the denominator. So I'm going to multiply by the square root of 3 over the square root of 3. So 27 times the square root of 3 is 27 square roots of 3. The square root of 3 times the square root of 3 is just 3. Then you just have to reduce that. 27 divided by 3 is 9. So x equals 9 square roots of 3. So I have y equals x, which equals 9 square roots of 3. So that part's done. And then x equals 2x, so the hypotenuse equals 2x. So I'm just going to have 2 times 9 square roots of 3. Multiply that 2 and that 9 together, and you get 18 square roots of 3. Okay? Let's do another one. So again, label the sides. So the hypotenuse is 2x. So x equals 2x. The side opposite of 30 degrees is x. So 5 square roots of 6 equals x. And then side opposite of 60 degrees is x square roots of 3. So y equals x square roots of 3. Now I'm going to take what I'm given, set that equal to each other. So we have x equals 5 square roots of 6. That's already solved for x, so we don't have to do anything there. Let's just plug that in up here. So 2 times x equals 2 times 5 square roots of 6. 2 times 5 is 10, so that's 10 square roots of 6. Okay. Then for y, we have x square roots of 3, so I'm going to plug in 5 square roots of 6 for x. So that's 5 square roots of 6 times the square root of 3. Well, when you multiply there, like notice up top we multiplied outsides with outsides. Now I'm going to multiply insides with insides. So that's going to be 5 square roots of 18. Then I have to break down that 18, see if I can pull anything out. So 18 breaks down to 2 times 9, which is 3 times 3. So I have those 2 3s, which means I can pull one out. So that's 5 times 3, and the 2 stays in there. So that's going to be 15 square roots of 2 is the side opposite of 60 degrees, my longer leg. Okay? Okay, let's finish just with doing some trig ratios. And I'll try and go through this fast. So we need to find the sine, cosine, and tangent of 45 degrees. So sine, there's my 45-degree angle. Let's label our sides. That's the hypotenuse. That's the opposite. That's the adjacent. Now, let's find sine. So sine is opposite over hypotenuse, which is x over x squared roots of 2. Those x's cancel, and I'm left with 1 over the square root of 2. But I have to rationalize that denominator, so I have to multiply by the square root of 2 over the square root of 2, and you get square roots of 2 over 2. Okay, let's do the same with cosine. So cosine is adjacent over hypotenuse, which is x over x squared roots of 2, which is the same exact thing as sine. So you still rationalize the denominator in the same way. Okay, tangent is opposite over adjacent, which is x over x, which equals 1. Okay, let's go to sine. So I relabeled my sides. Now x is the opposite side. The adjacent is x squared roots of 3, and the hypotenuse is 2x. So we're doing sine of 30 now, so we're using the 30, 60, 90 triangle. So sine is opposite over hypotenuse, which is x over 2x. Those x's cancel, and it's 1/2. Cosine is adjacent over hypotenuse, which is x squared, so 3 over 2x. Those x's cancel, and you're left with the square root of 3 over 2. Then tangent is opposite over adjacent, so that's x over x squared root of 3. Those x's cancel. You're left with 1 over the square root of 3. Rationalize the denominator, multiply by square root of 3 over the square root of 3. And you get the square root of 3 over 3. Okay, last one, so sine of 60. Again, opposite and adjacent switched places this time. So sine is opposite over hypotenuse, which is x squared to 3 over 2x, which is the square root of 3 over 2. Cosine is adjacent over hypotenuse, so that's x over 2x, which reduces to 1/2 because those x's cancel. And then tangent is opposite over adjacent, which is x squared to 3 over x. Those x's cancel, and you're just left with the square root of 3. Okay, this stuff might seem super silly right now. It's going to be super helpful, though, when we do the unit circle. So please make sure you understand this. It'll make the unit circle so much easier, okay? Remember to take the quiz. I'll see you tomorrow. I'm so sorry about the length of this.